In this video, we'll continue exploring data with tables and graphs, and we'll discuss the graphs that enlighten, gives us better understanding of data, and the graphs that deceive, create misleading impression about data. Technology provides us with powerful tools for generating various graphs. In the previous two videos, we learned how to construct a histogram manually and using StatCrunch and Graphing Calculator. If you haven't seen them yet, check them out. Now we will look at other types of graphs. A dot plot is a graph that shows quantitative data values as plotted points along a horizontal scale. This particular dot plot displays pulse rates of males. We can see that pulse rates range from 40 to about 104 beats per minute. Each interval of 10 is divided into 5 segments. We can count how many subjects had a particular pulse rate because each dot represents a subject. 1, 2, 3, 4, 5 people had a pulse rate of 52, and so on. One of the features of dot plots is that we can recreate the original list of data value. Another feature is that we can see the shape of distribution of the data and where the mean might be located. A stem plot, or it is also called stem and leaf diagram, is a graph for representing quantitative data as well by separating each value into two parts. Stem on the left that displays the most left digit, and leaf on the right that displays the most right digit. This particular stem plot shows same data as in the previous example, the pulse rates of males. The benefits of a stem plot is that not only we can count and recreate the original list of the values, 5, 0, 50, there are 2 zeros, so there are 2 subjects with pulse rate of 50, 1, 2, 3, 4, 5 twos, so there are 5 subjects with pulse rates of 52, and so on. But also, the data are sorted, and we can see the distribution of the dataset. The time series graph represents quantitative data that has been collected at different points in time, so we can tell the change in data over time, such as monthly or yearly. Scatter plot is a plot of paired quantitative data with a horizontal x-axis for first variable and vertical y-axis for second variable. From a scatter plot, we can determine whether a correlation and what kind of correlation, if any, exists between two variables. For example, this scatter plot shows data from arm and waist circumferences. We can clearly observe that some correlation does exist between these two variables because they have a distinct pattern, in this case, increasing. However, in this graph that depicts pulse rates and weights, the plotted points do not show any correlation. They scattered all over the graph. We will learn more about correlation and regression later in the course. Now, let's look at the graphs that are used for representing qualitative, categorical data. Bar graphs used to represent categorical, qualitative data. There are 2 types of bar graphs: vertical, when data presented in vertical bars, and horizontal, representing data in horizontal bars. The benefit of a bar graph is that it makes it easy to see the distribution in different categories. Pareto chart is one of the varieties of the bar graph, except in Pareto chart, the categories, bars, are arranged in ascending or descending order, so we can easily see the distribution of categorical data and identify the more important categories. A pie chart is very common but not very popular among statisticians type of graphs for displaying categorical data as parts of a circle. For example, this pie chart shows the types of stolen boats. We can see that the most stolen boats are jet ski and motorboats, and the least are sailboats. Something that probably the insurance companies will look at for identifying the insurance price coverage. Frequency polygon is a graph created from connecting the class midpoints in the histogram. Remember the histogram we built in previous video from a set of data of the drive-through service times for McDonald's lunches? Relative frequency polygon is a variation of a frequency polygon in which relative frequencies, proportions, or percentages are displayed in the vertical scale. Frequency polygons and relative polygons are good for comparing different sets of data. This relative frequency polygon displays data from 2 sets: service time measured at McDonald's and Dunkin' Donuts. We can see from this graph that the mean service times for McDonald's is approximately 150 seconds, and Dunkin' Donuts' mean service time is around 99 seconds. But remember, be critical when reading graphs. Why do you think Dunkin' Donuts' mean service times is less? Correct, probably because of the different menu and variation of the items. We also need to be critical when reading graphs, how they're presented. Some graphs can be misleading by projecting a vertical scale that does not start at a zero and only covers the top of the graph, which automatically disproportions the data. Or the pictographs that represent data as pictures. For example, these two particular pictographs compare the number of US smokers in 1970 and 2013. Although the number of smokers decreased only twice, from 37% to 18%. The graph drawn as three-dimensional cigarettes create an impression that the number of smokers decreased more than twice. So today we learn about few types of graphs: histograms, dot plots, stem plots, time charts series, scatter plots, frequency polygons for describing quantitative data, and bar graphs, Pareto charts, pie charts, pictographs for describing categorical data. There are many other types of graphs. Some of them were not even discovered. Maybe you'll be the next person who creates how else data can be represented. Let's keep in mind these principles. For small data sets of 20 or less values, use a table instead of a graph, and use graphs to display large data sets. When creating a graph, also remember, the graphs are excellent tools for describing, analyzing, and comparing data, and should help us focus on the nature of data rather than disruptive design elements.